node index.js.
Aww.
And all right, hey there, I'm Josh, developer advocate here at Zeplin, and this is the second video in our series for Zeplin's JavaScript SDK, and today we'll be talking about downloading screen images. Now, Zeplin already makes this super easy in the app by clicking and dragging a screen or a group of screens from the Zeplin app to your desktop. But we've had some users mention that they may need to retain printed copies of their screens for compliance reasons, or maybe they need to export screen images to another project management tool, or just simply have a backup of screen images. And when you're in a workspace that has a large number of projects and screens, all that clicking and dragging could get cumbersome, and that's why we are here today. We'll continue building off what we did in our first video in this series on installing and authenticating Zeplin's SDK. So if you haven't seen that yet, I'll leave a link to it down in the description, and you can go check that out and come back here when you're ready. In addition to the Zeplin SDK, you'll need to install a few extra packages. You'll need Axios for our HTTP request handler to access the Zeplin API. And the rate limit for a request to the Zeplin API is 200 requests per minute per user. So if you're working with a lot of screens to download, we'll also use the Axios rate limit library to help make sure that we throttle those requests. Now, downloading and writing so many files at a time can be taxing on your system, so similar to rate limiting, we'll be using the plimit library to limit the number of concurrent promises running at a time. And we'll be writing a command line application without any real front-end UI, so it'll be helpful to have an idea of how far our progress is in downloading everything. So we use a library called progress to visually represent the progress in our command line. And lastly, you'll need .env. And in our earlier video on authenticating the SDK, we dropped that personal access token in the code, which is probably fine when you're just trying to get up and running quickly. But this time around, we'll create an environment file that's git ignored to safely store your personal access token and any other environment variables for this app. And now taking it over to our node project index.js file, I've gone ahead and imported all the libraries that we just installed. There's also the built-in FS module, which is used for making any changes on your local file system, which is how we handle creating any directories and files that we download. You should also create an environment file.env in your root directory right here and paste in your personal access token and workspace ID. And then we can destructure them right here from process.env. I've also defined the parent directory name to store all of our downloaded screens, which I've called output. The process for downloading screen images has three main steps, and we can take a peek at Zeplin's API reference here. So the first step is to get a list of IDs for all of your projects in your workspace. And next, using those project IDs, you'll receive screen data for each of those screens inside that project with the get project screens endpoint. We can see that from the API reference, this will return an array of screens, and clicking here will show us some more information about the screen model, which includes a URL for that screen image. Lastly, we'll iterate through that list to download each screen by creating a file with the FS module and downloading the screen image data into that file. We'll set up our HTTP handler first, and now Zeplin's JavaScript SDK already uses Axios to handle any requests, but accepts a custom handler as a third argument, and we're going to use Axios rate limit for that. We'll call on the rate limit function and pass in axios.create to use Axios as the handler, and then a set of options where we want to have the max number of requests to be 200. That's per 60,000 milliseconds, which is 1 minute. So now we just need to update the third argument of Zeplin API to be HTTP, which is the new rate limit handler we just created. And the second argument is for more advanced scenarios using a different hostname for Zeplin's API calls, but we're just going to be using the default api.zeplin.dev so that we can leave this as undefined here. Now we'll get an async function started called getAllProjects. Then we'll create an array for those projects to live in and a variable called data, and then we'll start a do-while loop. So our data will be right here from await zeplin.organizations.getOrganizationProjects, and we'll pass in the workspace ID that's from our environment file. I've used the terms organization and workspace a bit interchangeably so far, so I'll clear that up a bit. So in 2021, Zeplin added a new pricing option called the Team Plan, which has a workspace concept just like our organization plan, but at this time of this video, the API uses the organization naming convention. So I'll continue using that, but if you're on a team plan, you can still use the organization endpoint. Now looking back at this getOrganizations project endpoint, we can add an additional parameter for the offsets and the limit, which will be 100. So we'll push that data into the project array and increase our counter, while the length of our data is equal to 100. This means that since we set our limit to 100, if we see that 100 projects were returned, it would indicate that your workspace has some more projects, so this function will go through that loop again to get the next set of 100. Now we're going to be writing a couple more functions just like this, so let's wrap this all up into a single function called main that we can call when we run this script. We'll console log the number of projects that we returned here and then call the main function. And now let's try it. I'll just type in node index in a new terminal window here, node index, and see that there's 3 projects in this workspace. Perfect. So we can check out Zeplin's API docs again in the project model and notice that it includes information like the ID of the project, name, description, and other helpful data to summarize that project. And since we have access to those project IDs, we'll use that now to create a function for retrieving a list of screens on that particular project. So we'll have a new function here called getProjectScreens, and we pass in the project. And something to note about the screen model is that it does not include the name of that project. So we'll hang on to the project name by creating a variable and adding it to the screen model. This will help later on when we're trying to save our screens in a specific directory that's named the same as that project. So we can destructure that project name from the project's data here. And to make sure that we're not confused with the screen name key, we'll just rename it to project name. And we'll also take the number of screens property also. And now when we call the getProjectScreens endpoint, we'll set a limit to 100 screens at a time. And the number of screens property that we have access to from the project model will help us calculate how many batches of 100 we'll need to iterate over to collect all the screen data. My sample workspace just has under 100 screens, so we'll just do 1 batch for us. Now each of those batches returns an array of screens, so you'll just need to make sure you flatten that array before you can use that data in the next step. And as I mentioned before, with the screen model not having a reference to the project name, we'll just map over these results once more and add the project name key to each screen object. And at this point, we'll have screen data with the URL of the image, and we can write our function for downloading that image. Now we have an async function I'll just call downloadScreen, and we'll want to pass a single screen object here, and then later on we'll iterate over the entire list of screens to run this function. Next, we'll destructure the screen name and the image, which will do another destructure for the original URL property and the project name that we added to that screen object just before. Again, feel free to take a look at Zeplin's API reference for some more info on all these models to get some familiarity with the data you have available. Now in this variable called data, we'll use Axios to get the URL, setting response type to stream. Here, when we first call fs, we make the directory with the project name, and this variable dir, or dir, is what we set our output directory to as a folder called output before. And you may want to git ignore this folder to prevent the entire contents of that folder from being committed. And then we'll write the file to that directory with the write file method. And these are PNG files, so we can set the file type here. And the contents of that file will be the data that we got back from the response. Now back in our main function here, we'll create a variable called screens, and that's where we'll iterate through all of the projects to get all of the screens put together in a single flattened array. And now we're ready to put all these individual requests together with the plimit library I mentioned earlier to help us manage the concurrent downloads. We'll get an instance going of plimit with a limit of 20 for now, but you can increase or decrease this as needed. And then we'll map over our screen list, creating a limited promise array, and then run promise.all on those to manage all the downloads. And actually, before we run it, we've just got to use the fs module to create the directory that we called output. And just for good measure, we'll make sure that we remove that output directory first in case it already exists, so the script can run nice and fresh and you won't have to worry about overwriting. So we'll just get another terminal here and node index.js. This happens pretty quickly, so let's see. We see our output folder being created and that our projects were logged and 23 screens were logged here. Great. So something to keep in mind here is that if you have a really large organization with many projects, all those screen images could easily lead to several gigabytes of data, so you may want to consider adding some logic to filter which projects have their screen images downloaded. For example, I've added a simple filter here to only return projects with an active status. Now, it's also really useful to get an idea of how your progress is going, which is where the progress library will come in. That way we'll be able to see how far along into downloading all the screens we are. So we'll create a new instance of progress, we'll call it screens bar, and we'll pass in a text string of what you'd like it to say with tokens that are prefixed with a colon, like the bar itself, the rate in BPS, percentage complete, and the ETA in seconds. Then we'll pass in an object of options, so the complete symbol for progress can be an equal sign. Incomplete can just be an empty space, like the space between my ears, and a width of 20 spaces. Now, progress also needs a reference to the total length to make the calculation on how far we are in that progress, which is, in this case, the length of our screens. And we'll pass in this progress bar to our download screens function as screens bar. And then in our download screen function, we'll make sure to include progress in the parameters, and then progress.tick will move the progress bar forward. Now we can run it again to see that progress bar in action. Now again in the terminal, we've got node index.js, and see that we've got fetching screens, and the progress bar completes right there. Nice. All right, well, thank you so much for joining me on this journey. I hope it inspired you a bit on what can be possible with Zeplin's API, and I'd love to hear about what you've built down in the comments, or join our Discord community to keep the discussion going or get any help from us. I'll see you next time.